Hi
Hi
guys,
guys,
I am Billy Lara,
and I'm Emika Velo.
and we are here to discuss the biomechanical analysis of the water polo penalty shot by college players.
So water polo is played by two teams with 7 players each attempting to score goals. There is a variety of throws you can use to score a goal, but we will focus more on the penalty shot, which is a crucial shot that can determine a game. So the purpose of this paper is to analyze the shooting mechanics of competitive water polo players, discover biomechanical variables affecting the said shooting mechanics, and to implement interventions for improvement.
So next up is the methodology.
The participants are all male competitive water polo players, and they will be split into two groups of five. The first group will be tested for the force of the throw and the body angles, and the other group will be tested for their leg power. Out of the 5 members per group, two will be assigned as the control subjects, while the other three will be for the experimental subjects.
For the variables, first we have the variables to be observed are the throwing angles, height at which the ball was thrown, the speed of the ball, and the force of the throw. The
And
constant variables will be the distance of the player from the designated goal, which is 5 meters, which is the standard distance of the penalty shot, and the target at which the players will aim for. Next. So first, getting the throwing angle. So all videos will be shot from a camera which is 5 feet above the player, and so this will coincide with the throwing power test because just like that test, speed is a factor here, and the rotational angle will be taken from the preparation phase, which is the stance in which you before you throw the ball up to the end of the throw when the ball will be released. The next is the simpler one, getting the strength of the egg beater kick and the height at which the ball was thrown. So the camera will be positioned 2 feet behind the player, and the max height of the ball before it is thrown will be taken into account. Next is getting the force of the throw and the speed of the ball. So we used a Bushnell radar gun for this, and we took into account acceleration via the sensor kinetics accelerometer app. So we got the instantaneous acceleration during different phases of the penalty shot. So first, during the forward swing phase, which is when the arm starts accelerating downwards, we got it. We got it. We got the instantaneous acceleration along the z-axis. Then the follow through phase, which is the actual throw, which is when you release the ball. We got the acceleration, instantaneous acceleration along the y-axis. Then for the force, we simply use the formula mass times acceleration, and we calculated it. So this is the example of the equipment, the accelerometer, the GoPro, and the Bushnell radar gun. So for the interventions, for the force of the throw, we focus on speed power. So we focused minimal number of sets and an average number of reps. So the exercises we wanted to focus on exercises that mimic the actual throwing movement. So we put the tricep push down, lateral dumbbell raises, med ball shot put, stretch cord tricep pull, and the grip strength exercises. So the grip strength is important because during the follow through phase, which we'll explain later, players tend to just push the ball when they throw it. There's no follow through. So in order to have a good follow through, you need good grip strength in order to have a good grip on the ball. So an example of the stretch cord tricep pull. For leg power, we focus on explosiveness. We focused on again speed power and explosiveness of the legs to blast out of the water to get a good throw. So we put lateral squat, lateral power step up, pistol squat, the dumbbell squat and clean, and box jump as well. So we focused on explosiveness in the glutes and quads. So an example of the dumbbell squat, side lunges, and the side squats and the power step up. So for the results and discussion, first we have the tables of the throwing power pretest. So as you can see, the acceleration z, which is the instantaneous acceleration taken during the forward swing phase, and the acceleration y, which is the instantaneous acceleration taken at the follow through phase. And we have the weight, and then we multiply the acceleration and weight to get force g and force y. Then we got the speed via the radar gun of the throw, which is in kilometers per hour. So you can pause the video to see the actual numbers if you want to see it. So now this is the post test. So this table shows the means of the pre and post test between the force Z and force Y and the speed. So first, intra-trial observation shows that the acceleration and force Z have significantly greater values than acceleration and force Y, meaning there's more acceleration and force during the forward swing phase as compared to the follow-through phase. So the follow-through phase is classified as a deceleration phase because it has to do with the slowing down of the arm prior to the release of the ball and the follow-through after the ball is released. The contraction of the posterior deltoids, rhomboids, and trapezius along with the muscles of the rotator cuff start decelerating the arm prior to release. So next, when shown the results of the post-test, both the controlled and experimental groups have all of their post-test greater values greater than their pre-test, with the difference being in the magnitude of the difference. So the control group experienced a less than one deviation from the pre-test, while the experimental group had a greater than one less than two deviation from the pre-test. So another thing is the interrelatedness of the force Y and force Z with speed. In table 5, the post-test results of player 1 and player 4 and player 5 had similar acceleration Z and therefore similar force Z. However, despite the similarity, their speeds were dissimilar. This can be attributed to the difference in the force during a specific phase. So that phase being the follow-through phase. So what happened is that player 5 had a slower or less strong follow-through phase as compared to player 4, which is why despite their forward swing phase being similar, they had drastically different speeds, relatively. So for the body angles, as stated, the angles were taken during the preparation phase to see the complete rotation of the players when they shoot. The intervention we used was to simply increase the angle and rotation of the trunk and torso as compared to what they got during the pretest. The results show that this increase in rotation, which was derived from the increase in angle, resulted in faster shots. So a good shot uses greater shoulder and trunk rotation to throw the ball and not arm flexion and extension. Due to increased body rotation, players can increase the power of their shot. The larger muscles of the trunk act first, producing trunk rotation in the direction of the throw, and this trunk motion can also assist in producing ball velocity during the throw. So again, all the players experienced improvements in the angles and speed, with their difference simply being in the magnitude of the difference. So this is an example of the body angle rotation of two different players. So lastly for the leg power, the player's throwing arm length and height were taken into account in order to see the degree of improvement, if any, in relation to their respective heights. Because a taller and longer limb player will naturally have an advantage in this test as compared to a shorter player. So most of the post test results were greater than that of the pre-test, except player 8. And player 8 was actually the tallest and released the ball at the highest height. In terms of improvement, however, player 7 had the best result if you compare his improvement in relation to his arm length and height. So the height of the ball at which the ball was released is an indicator of leg power. As the shoulder rotates backwards to prepare for the throw, is the egg beater kick. It increases in speed and helps raise the body out of the water in preparation for the actual release and the actual throw. So here are examples of the height at which the ball was thrown of two different players.
So to know the significance of our study, we use the independent t-test. We input our data in a software called SPSS. So we can see in the table that the pair 1 is the comparison of the force Y in the pretest and the post-test. Pair 2 is for the force Z, pair 4 for the speed and kph, and pair 5 for the height of the ball, and pair 6 for the body angles. To know if it is statistically significant, the level of significance must be greater than the p-value, which in this table is the sig2 tailed right here. Since we chose 0.05 as our level of significance, we can see that statistically everything is significant except the height and the speed. So for our conclusions, first, 180 degrees is the optimal rotation angle of the body during the preparation phase. Second, the leg power of course, one of the most important aspects players should never forget. Third, strength and conditioning is a good intervention for water polo players to improve their leg power and the force of the throw, especially if they have better equipment.
Lastly, for the application, so the entire cycle of the throwing motion is important, and it contributes to the overall speed and force of the throw. So, what coaches, strength and conditioning coaches, skills coaches, coaches in general, what they can do from what they can learn from their studies, they can learn to segment their training programs based on different phases of the water polo shot or different phases of anything in general. So different phases use different muscle groups and have different biomechanical aspects. So coaches can adjust their training programs in accordance to each phase of the shot. So an important aspect you can learn is segmentation of training programs. Thank you, and we hope you guys learned something from this. Uh, Biomechanics is a good, very good way of handling training programs. So we hope that you can actually use this study in your training. Thank you.